Welcome to Minatech. I am Francis Balestra, Director of the Sinano Institute. Please follow me. The Sinano Institute is a non-profit association representing 20 leading laboratories in Europe, coming from 11 European countries. The aim of the Sinano Institute is to establish a long-standing network of researchers in order to form a European network of excellence in the field of nanoelectronics. For instance, we are working presently with dimensions between a few nanometers and a few tenths of nanometers. These nanostructures will be needed for the integration of billions of nano devices for future integrated circuits, which will be integrated on very small silicon chips. The strategy of the Institute consists in the coordination of the main representative of the European academic community, together with the strengthening of the collaboration with the European industry. This overall collaboration in the field of nanoelectronics in Europe will allow to strengthen European efficiency in nanoelectronics. Nanoelectronics will be the basis of many very important applications in the future, for instance computing, communications, transport, health and environment, which represent about 60% of the world economy. The Sinano Institute covers the main nanoelectronic domains. The more one, devoted to ultimate CMOS, which is needed, for instance, for high-performance mobile phones and computers. The beyond CMOS domain for overcoming the limits of the scaling of CMOS. And also the advanced more than more field, mainly devoted to sensing, energy harvesting, RF application, and localized cooling on a chip. We are particularly focusing on the convergence of the more than more, and beyond CMOS field in order to develop advanced nanoscale structures, in order to improve the performance of terascale integrated circuits together with the performance of future nanosystems. We have to say that we are facing many challenges in these multidisciplinary researches, and we need federated effort from the main actors coming from nanoelectronics, but also coming from nanoscience and nanotechnology, coming from biology, chemistry, and also circuit and system design. This nanosystem will be very important for future application, for instance in the field of wireless sensor network for environmental monitoring, for ubiquitous wireless mobile electronics. The Sinano Institute's purpose is to play an important role in European structuring and program. Our organization also elaborates roadmaps, training activity, university curricula, and workshops in order to develop high-level competence in the field of nanoelectronics in Europe. The Institute gathers the most important flexible research infrastructure with three main platforms. The modeling platforms, devoted to the prediction of the performance and properties of nanoscale devices. The processing platform dedicated to the fabrication of innovative nanoscale structures. And finally, the characterization platform, which is needed for detailed evaluation of the properties of the integrated nanostructures. So let's start with the Sinano modeling platform, which will be presented by Enrico Sangiorgi from IUNET, University of Bologna. Please, yes. Enrico.
Thank you, Francis. The joint modeling platform is used to predict the performance on very advanced devices for different applications and compare technology options, materials and device structures in order to decide in advance which are the best for future technologies, and that is done before the use of the very expensive processing platform. The frame of the modeling platform, the most advanced modeling tools are used to study the challenging physical effects foreseen for the future technological nodes, namely the mobility enhancement due to stress and strain effects, the off-currents, the interface effects, the effects of low dimensionality of the carrier transport, and the effects of the different sources of variabilities on the devices.
Devices with very short gate length and strong lateral confinement, as silicon nanowire and double gate MOSFETs, are strongly influenced by quantum mechanical effects. By exploiting a non-equilibrium Green's function technique, we are able to solve the three-dimensional Schrödinger equation with open boundary condition and to compute the electronic wave function in the device. The quantum solution is self-consistently coupled with the Poisson equation in the presence of surface reference and phonon scattering in order to obtain important information on current density spectra, transfer characteristic, low field mobility, local density of states in the two devices at different silicon thickness.
Most of the software tools developed by the partners are based on a very complex equation called the Boltzmann transport equation, and they also take into account the issue of the low dimensionality. Also, there is another part of the modeling platform which is devoted to compact modeling, where a number of transistors are considered together, and each of them is described by a higher level description. For example, we are studying how to predict the transistor performance boost promised by different technology options. We are working on novel structures for even smaller, faster and cheaper memories, on smart sensors, on solar cells.
Thank you very much, Enrico, for your presentation devoted to the Sinano modeling platform. Now let's move to the presentation of the Sinano processing platform, which will be given by Michael Osling from KTH Stockholm.
The main interest we have is to go beyond the coming technology nodes, and the way we have found to be efficient here is to combine several of the top university labs in Europe. So one thing which is unique with this Sinano Institute is that we can really combine the different state-of-the-art labs in a very clever way, where we can have flying wafers. Flying wafers means that we can send the wafers among the different labs, and we can get unit processes done. And that could, for example, be energy harvesting. We could have nanosensors. We are exploring radio frequency devices and so on. We have explored the very delicate gate stack with high K dielectrics combined with a metal gate electrode. And one more thing we have explored is to make really low resistive contacts by using something we call dopant segregation of Schottky barrier contacts. And we are doing that at several labs, and we are comparing results and trying to understand this physics, the mechanisms in getting the really low resistances to source and drain regions.
Partners of the Sinano Institute are equipped, share or have access to a large variety of a complete set of advanced equipments. Those include deposition systems such as sputtering or evaporation tools, LDCVD and so on, to deposit materials down to the atomic monolayer. Etching systems such as chemical baths, reactive ion etchers, patterning systems such as UV, deep UV and E-beam lithography, nano imprint that allow to define feature size down to a few nanometers. But also chemical mechanical polishing, rapid thermal annealing, in situ characterization tools such as E-beam microscopes, XPS and so on. Technological equipments for more and more MEMS and NEMS are also available. Those include double-side alignment lithography, wafer bonding, supercritical CO2 dryers and so on.
For the work that we expect for the future, for example, further explore carbon-based electronics. We also see now with the Nobel Prize in the material graphene, so we are very well suited to continue that kind of work. We have the facilities to explore spintronics and various new technologies.
Now, let's move to the last platform devoted to nano-characterization, and Valeria Kilczyńska from Université Catholique de Louvain is going to present the main activity of the Sinano characterization platform. So Valeria, could you present the main activities of the Sinano characterization platform, please?
Okay, the characterization platform of Sinano Institute is used to test properties and performance of different advanced devices and integrated circuits. We look on their operation mechanism in order to understand them and to key parameters needed for further technology optimization. The strength of such a joint platform is to give access to a wide range of characterization techniques beyond what no any laboratory in the world could afford. Within our characterization platform, we continuously upgrade and develop our characterization technique in order to be able to proceed with emerging devices and materials. Of course, this is done in a strong collaboration with model development. Electrical and physical characterization technique are available. We complete them with optical and vibration technique. A special attention is paid to reliability and variability in these devices, as well as to operation under harsh environment conditions.
We'll give only a few snapshots for illustration. For instance, we use electrical characterization to understand the operation mechanism of ultra-small CMOS devices. By investigating the influence of temperature, magnetic field, mechanical strain, or such other parameters, we can separate intrinsic limitations from those that can be suppressed by technology improvement. We address a wide frequency range, which extends to RF or high-throughput digital applications, not only at device level, but also at circuit or system level. Finally, it should be stressed that our characterization capability is able to address new fields, such as the integration of sensing or energy harvesting functions. This experimental setup is just one example. Here, we are able to measure the piezoelectric effect in nanowires using near-field techniques at nanoscale in view of harvesting electrical energy from mechanical vibrations.
Our characterization platform operates under a flexible and open model, which is possible only within an academic environment. We provide an access to our characterization platform of course, to all Sinano Institute members, but as well to other academic laboratories, to industry, and to SME. You should not forget as well importance of such a characterization platform for the student in our academic labs.
Thank you very much, Valeria, for the presentation of the main activity of the Sinano characterization platform.
You're welcome.
The Sinano Institute is becoming a renowned European research entity in nanoelectronics and is organizing every year high-level conference and workshop, for instance, the SDR workshop, and the European conference devoted to ultimate integration on silicon. It is also organizing training activity, for instance, the Sinano Modeling School and the MIGAL School, which is organized every year, and has recently published a book devoted to nanoscale CMOS. More information can be found on the Sinano website, sinano.eu.